All right, we finally are getting to the definite integral and doing things the way it's supposed to be done and intended. We have ourselves a regular term, so it's kind of like power rule stuff. For power rule stuff, if I give you the integral, okay, and I'm just going to use very basic stuff, x to the nth, what you do, dx, what you do is you have 1 over n plus 1 x to the n plus 1. So the first thing that I have to do here is use this power rule to integrate x squared. All right, so if I were to really show my steps, and I'll do this for this video, my n is 2. I'm going to do 1 over 2 plus 1, x to the 2 plus 1. Now I still have my limits of integration that I'm going to write out over here, and those limits of integration are going to be between 1 to 3. Doing a little bit of work, I have 1/3 x to the 3rd power, limits of integration. Now, since I have these limits of integration, we have to do the whole subtraction thingy that integrals do. So what you do is you write out what you got, 1/3, okay, but instead of saying x cubed, you plug in your upper limit. So 1/3, 3 cubed, close my bracket, minus 1/3, 1 cubed, close the bracket. And again, this comes from the idea of the antiderivative of the upper limit minus the antiderivative of the lower limit. And that's what I did. I rewrote this out, plugged in 3, rewrote this out, plugged in 1, subtract the one from the other. So it's just a little bit of math now, which is what this is. 1/3 times 27 minus 1/3 times 1, 9 minus 1/3 is going to equal 8 2/3. Okay? Fun stuff. Compute the definite integral where we have the integral between 0 and 1 of e to the x dx. Well, this is a fun little rule. The integral of e to the x dx is just e to the x. So what I do is I take the integral, e to the x, I carry along my limits of integration, which are still just 1 and 0. Remember the rule, when you integrate and you have limits of integration, you take the antiderivative, which I just did, right? Plug in the upper limit, plug in the lower limit, subtract the upper one minus the lower one. So in this case, I have e to the x, upper limit is 1, so e to the 1st power minus e to the x, plug in the lower limit, e to the 0 power. E to the 1st is e, anything to the 0th is 1, e minus 1 is going to be our guy. Compute the definite integral, the integral between 0 and pi of sine x dx. The integral of sine x is not cosine. That's the derivative. The integral of sine x is negative cosine. Now we're going to carry along our limits of integration, which are 0 and pi. Remember, when you integrate and you have an upper and a lower limit, you take that antiderivative, which I just did, plug in the upper limit, minus, take the same thing, plug in the lower limit. That's what I'm going to do here. I'm going to say negative cosine of the upper limit, which is pi, minus negative cosine of the lower limit, which is 0. Okay, the cosine of pi is -1, so -1 minus the cosine of 0 is going to be 1, so -1. -1 is 1, -1 is 1, 1 plus 1 is 2. The answer is A, baby. Compute the definite integral. Well, we have the definite integral between 1 and 4 of 1 over x dx. The integral of 1 over x is ln of x. So this becomes ln of x, and my limits of integration are between 1 and 4. Now remember the rule, whenever you take the integral of something, you take that antiderivative, you plug in the upper limit, and then you plug in the lower limit, subtract the one from the other. So what I'm going to do is I'm going to write this out and plug in 4. So the ln of 4 minus the ln of 1. Fun fact, the ln of 1 is 0. So that just leaves you with the ln of 4, and that's going to give me a. Fun stuff. Compute the definite integral between 1 and 3 of 2x cubed minus 5x squared plus 4. Whenever you're taking the power rule and the integral, the rule looks like this. All right, if you're given, let's throw a letter in there, so cx to the nth dx, you're going to keep that c just kind of lingering there, okay? And then you're going to have 1 over n plus 1 x to the n plus 1, and then plus some arbitrary constant that we're not going to worry about right now. So what this is going to look like, okay, is this first term is we're going to keep the t lingering, or the 2 lingering right there. My n is 3, so 1 over 3 plus 1, x to the 3 plus 1. Okay, that's that guy. Let's do this one. Minus 5. My n here is 2. So 1 over 2 plus 1, x to the 2 plus 1. Okay. Now, if you're given just a constant, just attach x. Don't overthink it. So let's clean this. Oh, and by the way, with all of this, I still have my limits of integration of 1 to 3. I can't forget that. So let's clean this up. All right. This will be 1/4. So 2 times 1/4 is a half. X to the 4th power. Minus, this will be 1/3, so minus 5/3, x to the 3rd, and then plus 4x is much more manageable. Limits are 1 and 3. Now remember, when you're taking the definite integral, you find the antiderivative, which is that guy right there. You plug in the upper limit, you plug in the lower limit, subtract the one from the other. So I'm going to plug in 3, so 1/2, 3 to the 4th, minus 5/3, 3 cubed plus 4 times 3. Then we're going to do the same thing, minus, do the same thing, plug in 1. So 1/2, 1 to the 4th, minus 5/3, 1 to the 3rd, plus 4 times 1. Okay? And just some gross math. 3 to the 4th is 81. 81 over 2 is just 81 over 2. Minus, that's going to be 27. So negative 5/3 times 27 is the same thing as negative 5 times 9. So negative 45. I don't know why that took me so long. And then plus 12, I can handle that. Minus, all of these become 1, so are basically useless. So a half. Minus 5/3 plus 4. All right. And we're still moving. And we're still moving. 81 over 2 minus 45 plus 12 is going to be 15 over 2. 1/2 minus 5/3, 6 plus 4, 13 over 6. 17 over 6. Combining these is going to get you 14 over 3. Which is none of these. I don't know why I do that. I don't know why I kept that up there when I should have deleted that, because that's absolutely not true. So we'll pretend that that's not even there. But yeah, that's going to be my answer right there. None of those, none of those, none of those. Thank you, ChatGPT. You're letting me down again. Evaluate the integral between -2 and -1 of 4 over x squared. Well, let's rewrite this to the integral of 4x to the -2. Much better. And then we could use that power rule that says if I give you something that looks like this, right? If I give you something that's like x to the nth, when you integrate that, that becomes 1 over n plus 1 x to the n plus 1. So when we see something that now looks like that, we're going to kind of rip 4 out, okay? And then we're going to do 1 over, u would be my n, so 1 plus negative 2, so 1 minus 2, x to the 1 plus negative 2, so 1 minus 2. We still have our limits of integration, and those limits of integration are still going to be negative 1 and negative 2, but not in that order. I can't forget. All right, so this is going to simplify out to 1 over 1 minus 2 is negative 1. So 4 times negative x to the negative 1. Limits are negative 2 to negative 1. Let's rewrite that out one more time. Let's drop x to the negative 1 to the bottom and bring that negative out. So negative 4 over x with my limits being negative 2 and negative 1. Okay, let's plug stuff in. That's going to be, and remember the rule. Remember the rule, right? This guy. So we're going to plug in our upper limit. We're going to plug in our lower limit, subtract the one from the other. So the upper limit is going to be negative 4 over negative 1 minus negative 4 over negative 2. So negative over a negative is a positive. You just become 4 minus triple negative, so it's going to stay negative. 4 over 2 is 2, right? And you just get 2. Pretty nice. Evaluate the integral from 1 to e squared of 1 over x. Well, the integral of 1 over x is ln of x. And then the limits of integration come along for the ride. Remember, after you integrate, you take the antiderivative that we just found, plug in the upper limit, plug in the lower limit, subtract the one from the other. So what this is going to look like is ln of the upper limit, so ln of e squared minus ln of the lower limit, which is 1. Ln of e squared is just 2. Ln of 1 is nothing, and 2 minus 0 is 2.